On this example, we have a parabola that is in vertex form, which means we can easily look at it and pick out our vertex. Vertex is crucial for figuring out where the parabola turns around. You don't want to graph 5 points without including the vertex because your parabola won't look right when you go to graph it. We want to do an XY chart to get some exact points on this line. Now the first thing I want to do is pick out the vertex. So if I go up here to the equation, in parentheses with the x is a positive 2. So I'm going to take that out and make it a negative 2. On the end is a negative 1. That means my y value for my vertex is a negative 1. Now on my XY chart in the middle, I'm going to put negative 2, negative 1. I want that point to be in the middle. Now I need at least 5 points to graph this. So what I'm going to do, you can pick any points you want, but try and keep it easy. I'm going to pick 2 points to the left of that vertex and 2 points to the right. So if I go over here and I graph negative 2, negative 1, I go left 2, down 1. 2 points to the left would be negative 3 and negative 4. 2 points to the right of that x value would be negative 1 and 0. So we are going to plug those into that equation up top and figure out what points go with it. So let's try negative 4. If I plug in a negative 4 up here, I get negative 4 plus 2, which is negative 2. Then negative 2 squared would be 4, and 4 minus 1 is equal to 3. So over here on my chart, I'm going to put a positive 3. Now let's try another number. So let's go up here and let's try the negative 3. If I put a negative 3 here, negative 3 plus 2 is negative 1. Negative 1 squared is positive 1, and 1 minus 1 is equal to 0. So at negative 3, I'm going to put a 0 in my chart. Now the next number I'm going to try is going to be the negative 1. Negative 1 plus 2 is 1. 1 squared is 1, and 1 minus 1 is equal to 0. So I put a 0 here in my chart. I have one more to try. I'm going to see what happens when x equals 0. If I put a 0 here, 0 plus 2 is 2. 2 squared is 4. Minus 1 is equal to 3. So I put a 3 in my chart. Now one thing you'll notice is the y values are the same for negative 3 and negative 1. They are both 1 unit away from the vertex. Also, at negative 4 and 0, the y values are both 3. They are 2 units away from the vertex. Now the reason this happens is because of the axis of symmetry. You have an axis of symmetry for this equation, and that axis of symmetry goes through the vertex. So the axis of symmetry for this equation would be at x equals negative 2. In this type of equation where the x is squared, it always goes through the x value of your vertex. If you go up here and look at your vertex, it would be x equals negative 2. So I can use symmetry to graph this equation and make it easier. I could have done 2 points instead of having to do all 4. Now let's put these on the graph. When x is negative 1, y is 0. When x is 0, y is 3. When x is negative 3, y is 0. And when x is negative 4, y is 3. So this is the parabola that we end up with and that we needed to graph. Now we knew from the last chapter that this parabola should have gone left 2 based on this and down 1, and we knew the parabola was facing up because it was a positive 1 in front. So we knew it was a regular shaped parabola. You went left 2, down 1, and that it was going up in a normal parabola. What we've done this time is we've gotten exact points from the parabola.